much for joining me tonight. My name is Mehrtens. I'm an instructor and advisor in the School of MCB, and what I'm going to try to help you understand tonight is what opportunities are out there for you with a degree in MCB, some of which you're going to be very familiar with, others you may not have considered in the past. So one thing that often gets students started in this process is thinking, is MCB the right major for me? Are there opportunities out there? So I've got a great quote that I want to share with you. It's this: if cancer is to be cured, if solutions to the world energy crisis are to be found, if the planet's pollution is to be cleaned up, it'll probably be the biochemists and molecular biologists with the knowledge and skills to power these breakthroughs. This is one entity's way of saying, yeah, you're going to be marketable. If you get out of here with an MCB degree, you're going to be marketable. Now, I have to temper this just a little bit by pointing out the source of that quote. It was the American Society for Biochemistry and Molecular Biology. So consider the source. Of course, they're a little bit biased, but I think there's something to be said for that. If you have the knowledge and skills and dispositions that come along with getting through the MCB program, you are going to find success in something you do after college. So that leads you to why you're here tonight. What are my options after college? I am big into metaphors and analogies and examples, so my metaphor here is a tree. Notice that this tree has one big trunk at the bottom and then it branches into three equally large trunks. I like to visualize this as what you might do with a degree in MCB. You're all here right now, taking essentially the same classes, preparing for whatever might come, but the day is going to come when you have to decide whether you want to go down the health profession trunk of that tree, the graduate school trunk of that tree, or no more school for me right now, please, I just want a job. So branch number one is the health career professions. Branch number two, graduate school. And branch number three, getting a job right out of college. Maybe leading to going down one of the other two branches later, but not for right now. So we'll talk about each one of those branches. We're not going to spend a whole lot of time on the first branch because you're here to get information about things you might not already be aware of. I think everybody's aware that a student with good training in molecular biology and biochemistry is a good candidate for professional schools, but I don't want to ignore them altogether. So I want to mention that for anyone who considers themselves on a pre-health profession track, we can identify you as being a good candidate for that left trunk based on what your answer to this question is. What do you want to do for a living? If your answer is, I want to fill in the blank, what do you think would be the two words that follow for someone who's on a health career profession trajectory? If the question is, what do you want to do for a living? What do you think they're going to say when they say, I want to help people? That's what they all say. I want to help people. So yes, if you say you want to help people, now spoiler alert, everybody I talk about tonight is going to help people. But this is what the standard answer is for why do you want to be a doctor? Why do you want to be a dentist? Why I want to help people? So yes, I want to acknowledge that there are lots of professions in the health careers. In fact, it takes up a whole slide, and this is not an exhaustive list. So yes, we all are aware that people with degrees in MCB make good candidates for med school and vet school and pharmacy school and dental school and PA school. But there's also some health career professions that you might not have considered or perhaps even heard of before, like occupational therapy, speech pathology, genetic counseling. There are other ways to answer the question, what do you want to do for a living, and have the answer be, I want to help people, besides the ones that get all of the attention. So it does bear a few minutes. We should take a couple of minutes to talk about what does a person need to do to be prepared for those kinds of paths. So we're going to talk about this just briefly. I'm going to mention that for most of those professional programs, most of those health career programs, if you look at their basic set of academic requirements, we're not going to go into an exhaustive discussion about everything else you need to do. But the academic requirements typically look like this. You need a year of intro bio, a year of gen chem, 1 or 2 semesters of organic chemistry, maybe a year of physics, probably some advanced biology, including or maybe in addition to some anatomy and physiology. That's very, very standard for what you as a college student, regardless of major, need to do to meet the admissions requirements of most of those health career professions. Now, what does that have to do with being an MCB major? Are they aligned? Is there any overlap there? Well, if you look at the core coursework and supporting coursework for students in MCB, guess what it is? A year of intro bio, a year of gen chem, a semester of orgo with the possibility of a second, a year of physics, advanced MCB coursework, anatomy and physiology as an option. Yes, there's perfect alignment in this major for meeting the admissions requirements of virtually all of those programs. What makes one program different than the other, there are some subtle differences in course requirements, but then you get into what else do you need to bring to the table. And like I said, that's better suited for a how do I get into medical school workshop, not what can I do with an MCB degree, because like I've already acknowledged, we all know you could go to medical school with an MCB degree. You're here probably, presumably, to find out what other kinds of things can you do with an MCB degree. So I'm not going to focus any more of my attention on getting into a health profession school. The Career Center has health profession counselors over there that can help you with specific answers to questions about specific programs. How many hours of community service do I need to get into Loyola's dental school, if they even have one, that kind of thing. What we're going to focus on now is, if not medicine, then what? If I don't want to be in the health career path, then what am I left with? Well, that sounds like a pretty limiting question, doesn't it? The good news here is that was only one trunk of this three-trunk tree. We still have trunks 2 and 3 that we haven't even talked about yet. So the answer to the question, if not medicine, then what, depends on you. And I hate to turn the tables right back on you and say, you need to take ownership of your own path. But the reality is, you need to take ownership of your own path. This begins with some self-exploration. Find out where your interests are. Find out what you're good at. And in a perfect world, we could find a way to combine what you're being trained to do with what you love doing in your free time, and maybe even get paid for it in the meantime. That's what we want to do. We want to find a career path for you that helps you match your skills and dispositions with the training that you have acquired along the way. Sometimes that means more education is going to be required. Other times it means you might get a job after you've graduated from college and be perfectly happy. So let's start first with branch 2. Well, I guess it's the second. We've already talked about branch 1. Now going into branch 2, this is the graduate school branch. What do I do if I need more letters after my name? There will be more, and let's be perfectly honest about it. You get higher salaries and there's more opportunity for advancement if you have higher degrees associated with you. You have a bachelor's degree, you can get some jobs. You start getting master's degrees and doctoral degrees and so forth, other things that we'll talk about in a minute. Now you become qualified for other positions, higher salaries, more room for advancement. So yes, it may mean more, well, it will mean more time in school, but the end result is you have more upward mobility and you can command a higher salary. So there are some compelling reasons to consider graduate education at some point after you've finished your bachelor's degree, your undergraduate degree. So we think about, and again, in the spirit of me loving metaphors, think about the structure of who does what in a scientific setting with respect to degrees. What letters do they have after their name? I love a construction metaphor for this. My dad was in construction. I grew up around construction sites. I'm familiar with this model, that in the world of construction, if you want to build a dam or you want to build a skyscraper, there's somebody who's in a corner office making all the important decisions. That person is the project manager, right? That's the person in charge. The project manager is the one who has the vision and is out there, you know, shaking hands and raising money. This is the project manager. Now the project manager has assembled a team. Those team members are going to be given instructions, copies of the blueprint if you will, and said, I'm going to let you decide who you have working under you, but here's what I want your group to work on. And maybe your group does this, and your group does this, and your group does that. Those people, the middle of this three-tiered structure, in the construction world, those are called the foremen. All right, so those are the ones, yeah, they'll get their hands dirty if they have to. Hey, let me show you how to use this arc welder because you don't seem like you've been on the job very long. But really my job is to make sure that you're not breaking something, that you're getting your job done, you don't take too long of breaks. It's my job to kind of manage you, but I, the foreman, am not the one making the big decisions. That's the guy who I got the call from this morning, who's got the corner office with the good view. So in our construction metaphor, the project manager's in charge, the foreman is the one on site, making sure that the team is doing the right things, and then there are the hands. The hands, the people doing the welding, doing the cutting, doing the dragging and digging and whatever else, those are the laborers. Now this is in the world of construction and it's perfectly valid, but it's also a perfect metaphor for the world of science. Research science works this way too. The person in the corner office, the one making all the important decisions, you know, pressing the flesh and raising the money, those are the people with the PhDs. I'm not saying that this project manager has a PhD, but I'm extending my analogy here. In a scientific setting, the PhDs are the ones who make the decisions. They're the group leaders, the project managers, the ones making the important decisions. In my analogy here, the foreman is going to be somebody probably with a master's degree. In a laboratory research setting, the people with the master's degrees are getting instructions on what the team should be doing from somebody with a PhD, but they have some autonomy in how they help their team perform best. And then the people that we would call the laborers in this analogy are the people who get jobs right out of college. The people with bachelor's degrees, Bachelor of Science if you're an MCB student. So the people with the bachelor's degrees are doing the work. They are the hands at the bench. There's not a whole lot of upward mobility and not a lot of decision making. You can tell the person who's in charge of your group, I don't think we should do it this way, but you better be careful because you're not the one making that call. The person with the master's degree is the one telling your group, this is what I want you guys to work on today, and then the person with the PhD is the one making those decisions. So, we're going to talk at the end about maybe some things you can do with a job right out of college. Let's talk about those top two layers. How do you get a PhD? It's one thing to say, I want to go to graduate school and get a PhD, but that comes with an understanding at just how different it is than the model you're probably familiar with. You're probably familiar, whether you want to go to med school or dental school or pharmacy school or not, you're probably familiar with what med school might be like, and that you have to take this horrible standardized test to get in and so forth. You're probably familiar with that model. What I want to tell you is a graduate school is nothing like that. So let's talk about getting a PhD. If you want to get a PhD in science, it's called a Doctor of Philosophy. In the world of MCB, and of course we're talking about what you can do with an MCB degree, MCB majors can get into PhD programs easily, well, relatively easily, in any discipline that is within the school of MCB. So, in case you're not aware of this, the School of MCB is a lot of different things. It's the Department of Biochemistry, Department of Cell and Developmental Biology, Department of Microbiology, Department of Molecular and Integrated Physiology, the program in Neuroscience, and the program in Biophysics and Quantitative Biology. So, anyone who's trained as an MCB major could get into a PhD program in any one of those areas. What it entails is getting it, sometimes you need to apply to a specific program. Other times, you can apply to a more general program. I'll give you an example. On this campus, it at least used to be, I'm not sure that this is still the case anymore, you used to be able to, if you knew for a fact you wanted to be a microbiologist and you wanted to get a PhD in microbiology, you could apply directly to the PhD program in microbiology. Those would be the only classes you take. They're the only faculty members you had to choose from in terms of picking your research lab. But that's okay because you imposed that restriction on yourself. You knew you wanted to be a microbiologist. Well, what if you're an MCB major as an undergrad and you like a little bit of this and a little bit of that and you don't know exactly where you want to land? More and more institutions, like Illinois for example, are offering PhD candidates now the opportunity to apply to the umbrella program. Now, when someone's interested in MCB, they can apply to the School of MCB. And you have faculty members and labs and classes in every one of these departments and programs to choose from. It's a much broader pool to choose from when trying to decide exactly where you might want to end up. Because sometimes you know, I'd like to pursue graduate work, but I don't know whether I would like microbiology better than cell biology. I had one class in each. How do I know, right? That's a very legitimate concern. So maybe you don't have to know right away. Maybe you can apply into one of the larger umbrella type programs. So that's what it means to, well, that's what a Doctor of Philosophy is in a world of science. Now let's talk a little bit about the graduate program itself. Because like I said, this is going to be different than your pre-med friends who are fretting about paying $250,000 to get through medical school and being in debt for the rest of their life. For one thing, you get paid to get a PhD in science. Any reputable PhD program in science, pretty much in any STEM field, is going to fully fund you, guaranteed fully funding for the entire time you're in their program. It can come in the form of a teaching assistantship, you're a TA in a class like MCB 150, or it can come in the form of a research assistantship where once you've finished your classes and you've completed, because you have to take some of your own classes, once you've finished your classes and you've done the required teaching for the department, now your research advisor just wants to tie you to a bench and leave you there until you're finished. That's maybe a bit strong, but it's not that far from the truth. They want you at the bench as much as possible, so they're willing to pay you to stand at the bench and get data so that you can write papers, publish your thesis, and get out of here and go on and be productive and spread the word of how great your training was, making more graduate students want to come to Illinois. It's a very self-fulfilling thing. How long do graduate programs? Well, let me go into that by asking this. How long is med school? Mary, how long is med school? 4 years. How did she know that? Is she clairvoyant? No, that's just how long med school takes, right? How long is a PhD program? It depends. It depends on how well your research goes. It depends on how well funded your lab is. You may have to be doing some additional TA work because the department guaranteed you money, so you may have to TA more times than you expected to. I have known people who have been in graduate school for more than 10 years. I also know someone who got out in 3. Those are the extremes. I mean extremes of the spectrum. The spectrum is usually 5 or 6 years. Maybe 7 if things aren't going so well, maybe 4 if every experiment you run goes right the first time. That doesn't happen very often. If you've ever spent any time in a lab, you know that science often doesn't work the way we expect it to the first time. Plus, you never do an experiment just once anyway. So, graduate school takes a variable amount of time, depending on what questions you're trying to answer, how well things go, and ultimately how well funded your lab is and whether they can afford to pay you a research assistantship instead of a teaching assistantship. If you have a 50% teaching assistantship, that means you're not spending all your time at the bench, you're spending half your time at the bench and half TAing for this physiology class. That's the way that works. Now, they've guaranteed you the funding, and that funding doesn't go away. So it's a nice way to be guaranteed of, you know, you get your tuition paid for and you put food on the table, you don't rack up a whole bunch of student debt, but you're going to earn that money that they give you, and you're going to get a PhD to show for it. Typically 5 to 6 years. What can you do with a PhD in a scientific field? Just about anything. You know, this is another tree we could branch into, or could split into 3 branches. There's the academia tree, the industry tree, and the government tree. All of them good jobs, solid research team leader jobs. You go into academia, you're a professor. You go into industry, you're starting your own biotech company or your own pharmaceutical company. You're the brains behind it. You probably have a partner who's behind the money. So you're the chief scientific officer, somebody's the chief financial officer, and you're developing a new anti-cancer drug. All right, so that's the kind of thing that you can go out and do in the pharmaceutical world, in the biotech world, in the basic science world. You're the team leader. You go to work for the government, you could go to work for just about any government agency that hires scientists. National Institutes of Health, Center for Disease Control, the Department of Agriculture, Department of Energy, Department of Defense, Department of Homeland Security. All of these different agencies are looking for people who know something about DNA. And as an MCB major, if there's one thing you're going to know a lot about, it's DNA. All right, so that's kind of what happens with a PhD, the Doctor of Philosophy. Master's degrees, it isn't so clear. It isn't so not rigid, but so streamlined to describe in the world of master's degrees, because there's some variability here. Master's degrees, you can get a lot of different kinds of master's degrees. Traditionally, the big ones were, I'm going to get a Master of Science in Biology or a Master of Science in the teaching of biology. But over the last several years, a lot of new specialized master's programs have popped up. Ones that you might have heard of, like you probably heard of forensic science, but many of you probably have not heard of professional science masters. Or one that just came on our radar not too long ago, a Master of Engineering in Bioengineering. I wasn't even aware of that 2 months ago, and now here it is in my presentation. So new things are constantly being developed as well. Master of Medical Science is the kind of specialty program that I'm going to talk about in just a minute, because it has its own area here. But what I'm pointing out is that you can get a master's degree in a lot of different areas, kind of like you can get a PhD in a lot of different areas. These are just different, slightly different types of programs. All right, so that's the kinds of masters that you can get. Now let's talk about some differences between getting a master's degree and getting a PhD. In the world of PhD programs, they fund you. In the world of master's programs, they typically don't guarantee you any kind of funding. You will usually have to pay for some, if not all, of your master's program, but there are opportunities out there in certain programs to maybe get some subsidy, some money coming in by maybe TAing a class. And if you're in a research-based master's program, which I'll describe in a moment, that might extend your stay. Because again, the research is going to dictate how long you're here, and if you're not doing as much research because you're spending some time teaching a class because they're helping pay the bills, then you can expect to maybe stay a little longer. So just as with the PhD programs, with a master's program, there's no exit point. They're not going to say, it's 1 year and you're gone, unless it's all classwork based. So the duration, anywhere from a year to probably 3 years, depending on a lot of things. First and foremost, depending on whether the program you got into was entirely coursework based or coursework plus research. If it is truly just coursework based, then you get in, you take the classes in the semester they tell you to, and you get out. It could be a year or 18 months, and boom, you're done. There wasn't anything else keeping you there longer because you knew what classes you were going to take and you knew when you were going to take them. If there's a research component folded into it, it leads to additional opportunities that a classwork-based master's might not, but the cost, the flip side here is that it's going to take you a little bit longer because you're folding in research into that program as well. And then there is a group of students on every college campus nationwide, I guarantee you, who want to go to med school or dental school or pharmacy school and don't have the grades to be competitive after they've graduated from college. So there are a whole slew, new ones popping up all the time. Like every year, there's additions to this list of what are called post-baccalaureate programs. These also are specialty programs. Some of them are degree granting. Some of them will give you a master's degree once you've done what they've asked you to do. Others just give you a certificate of completion and a transcript. But in the end, what you cared about was the transcript. These are opportunities to take additional science classes and improve a math and science GPA after you've graduated from college and wonder, if my GPA was a problem and I've already graduated, how do I fix that problem? This is an answer to that. I know that a lot of students who are, they're not outright denied admission to medical school, but they're nudged. The school itself will say, thank you for your interest. Why don't you send in an application to one of our post-bac programs? That's their way of saying, we're probably not going to admit you, but we think you'd be a good candidate to show us that you're a better student than your academic history suggests you used to be. So it's more about how you finished than how you start. Who are you now? Not who were you back when you were a freshman taking Gen Chem 102, right? All right, so these programs they're expensive, but they're a nice opportunity to fix a problem that doesn't have any other outwardly obvious solution. Because honestly, how do you fix a GPA after you've graduated? It doesn't seem like you can, but yeah, you can. You take more classes. So these post-bac programs, some of them have special names, like on the previous slide. Let me go back a couple of spots right here. Now, on the slide when I showed all of those different master's programs, one of them was a Master of Biological Science, medical master's degree. Yeah, they come in a variety of names. Masters, Master of Medical Biosciences, those kinds of things. You know you're on to one of those post-bac programs when it sounds like that. Okay, now what I want to take the rest of my time before I open it up and invite your questions, I want to show you some stuff from the University of Tennessee Career Services Center. They've put so much effort into this that they have a website called whatdoidowiththisdegree.com. I'll put that up there on my last slide because it's a mouthful, but it's also an incredibly helpful website with downloadable documents that have everything that I'm about to show you. What I want to show you is what they've done. There's no reason for me to reinvent the wheel. they've put a great deal of research into the things you can do with a degree in biology. Some of these are going to be, sure, I saw that coming. Others like, oh wow, I never thought of that. So each one of these slides is going to be left, middle, right. On the left, it's what is the big header area. So this slide is about research and development. If you think, I want to be in research and development, then what does that maybe mean? Maybe you're in grant writing, or administration, or quality control, or and there are a couple of these I've added on to, I've amended it myself, genetic engineering of crops. Now, so that's the left-hand column, is the big header, what kind of job are you looking for, what area do you want it to be in. Then underneath that it's going to be, well, here are the different sub-areas that you might be interested in. Move over to the middle column, and the middle column says, here's who's looking for people with those skills. And then the right-hand column is, here's what you as undergraduates can do to prepare for that path. So every one of these big subject header areas is going to be laid out the same. In this one, research and development, who's hiring people in research and development? The kinds of, some of this is obvious, the kind of entities you would expect. Pharmaceutical industries, agricultural production, environmental agencies, state and federal government agencies like the Department of Agriculture, Department of Homeland Security, colleges and universities. Now, what would you as an undergraduate do to lead yourself down a path like that? You learn how to operate lab equipment. You do well in your lab classes. You get involved in undergraduate research. Maybe you complete a certification program of some kind to let them know that you're trained in this technique, and then you can get a job doing that thing. You'll notice at the bottom, it reiterates what I said much earlier. You're going to get farther if you have more letters after your name. More responsibility, more advancement opportunities, and higher salaries if you have advanced degrees. But this is not restricted to people with graduate degrees. We've now combined trunks 2 and 3 for this part of the discussion. This is what you can do either right out of college. If you do these things to get trained, then you can get jobs right out of college, or better jobs perhaps if you've got some advanced training. So that's research and development, biomedical sciences. Okay, this reads like an MCB list, doesn't it? Genetics, virology, immunology, biochemistry. This is the stuff MCB's made of. This, if you're thinking, I would love to find a way in a research setting to be involved in biomedical research of some kind. Well, where might you get a job? Where do you think? Colleges and universities, professional schools. You could get hired as a scientist, a staff scientist in some university's College of Pharmacy, or College of Dental Medicine, or College of Veterinary Medicine. There's all kinds of possibilities for where you might work. Again, government jobs, they're looking for things too. Clinics and hospitals, independent laboratories, the pharmaceutical industry. That's where a lot of this MCB-related basic science research is going to land you if what you're looking for is a job and not professional training. What are the strategies? A lot of that's the same, and a lot of these bullet points are going to be repeated because of the same things you can be doing to prepare for whatever you end up wanting to do. Get involved in research, find out if it suits you, get internships, meet other people in the field, shadow professionals in fields that you think you might be interested in. There are ways to get involved that lead to getting jobs. This is a good recommendation too. Join student chapters of professional organizations, and now you've got a common group of people that you can share stories with and ask questions of, and find out from people who maybe have done an internship at that company whether it's worth your time to apply for an internship at that company. So anytime you can gain information, knowledge is power, right? If you possess the information, you can make better informed decisions. So that would be biomedical sciences. Biotechnology, again, I don't need to read all of the same points because many of them are repeated. You see the same things pop up. Biotechnology companies, colleges and universities, government positions. These things are the same. Get knowledge of the industry. Make sure you've got good laboratory skills. Have a strong GPA to be competitive, because a lot of these biotech positions, other than the entry-level hands positions, are going to require that you have advanced degrees. Bioinformatics, possibly, of all of the subject headers that I'm going to show you, possibly the most exploding category that I've got here. the bioinformatics category is just, I mean, it's all about big data these days. Everybody is talking about how we can use data, massive amounts of data, to make better decisions. Put that in a biology context, if we can use computer-generated data, which can do it far faster than humans can do, we can sequence genomes faster. We can analyze health-related problems faster. We can watch how proteins fold in a simulated fashion and see if that's really what's happening inside a cell. So the world of bioinformatics is really rapidly advancing. And there's obviously a lot of things that you can do there. Again, internships, learn some software if you've got some computer science. Remember, one of the points that I made earlier was we need to find a way to combine what you like with what you're good at. Well, if you like dabbling in computers and you're good at biology, you might want to strongly consider something in the bioinformatics field, because they're looking for people who know the computer science and can understand how the biology can be layered on top of the computer technology and the big data analysis. Education. All right, you probably have considered that a lot of times, back in the old days like when I was in college, if you were a biology major, that meant you were either going to be a doctor or a teacher. Really, that's kind of what you were going to do. You're either going to go to grad school or med school. Well, those days, I hope I'm making the point that those days are long gone, but it doesn't mean you can't still go to graduate school to become a college professor. So there's the whole education header. At any level, you can be in education. And I mean any level. I love this one right here, non-classroom education. Why am I here tonight talking to you? Is it because I teach MCB 150? No, it's because I'm an academic advisor. I got hired as an academic advisor because I knew some stuff about biology, I've got some communication skills, and I had the appropriate degree. None of the advisors that I know, and I know a lot of advisors, went to school to become an academic advisor. But it's a job, and it's a darn good job. Every one of you has probably taken some courses, some laboratory courses, right? Or the big lecture courses that have coordinators. Who do you think those coordinators are? My course coordinator in MCB 150, that's a job. The course coordinator in MCB 250, the course coordinator in any lab class. Those are people with jobs to coordinate courses. That's non-classroom education. So you could get a job as an academic advisor someday if you've got good communication skills and you understand how to work with people and you're patient and so forth. It takes a certain breed of cat to be an academic advisor, but it's a job. And it's a job that you could get with your biology degree if it's something that interests you. So I'm encouraging you to think outside the box here in terms of what opportunities might be available to you. I also like the idea that non-classroom education can mean a tour guide at a zoo, or someone at a museum who helps kids understand the significance of dinosaur bones. That's non-classroom education. So be creative in how you find a way to combine what you like, hanging out in museums, with what you're good at, understanding the Paleolithic era. Right? There is probably a way to creatively combine your knowledge and your skills into a career that you'd be happy with. So think outside the box. Some of these positions are going to need other degrees. Some you can get with a bachelor's degree. We've got a couple more. Now we start to transition into the jobs that I think you probably weren't outwardly aware of. Now, maybe someone had mentioned some of these things to you, but probably not a lot of them. Communication. Anybody fancy themselves a good writer? Anybody think you're a good public speaker? There's ways to combine that with a degree in biology as well. If you're a good writer, somebody needs to explain to Joe Sixpack why he should be familiar with what's going on in the world of communicable diseases, right? That Joe Sixpack isn't going to be reading the primary literature, is what I'm saying. So if you get a job working for a magazine or a newspaper or some website that can distill the primary literature because you do understand it, you distill it down into Joe Sixpack language, that's a valuable service to humanity. It's also a good paying job. If you're good at drawing or painting or sculpture, You could get into making models or drawing scientific illustrations. Somebody has to draw the pictures in your textbooks. Some of them are better than others, right? Some of them have errors in them, right? You can be the one who draws the next generation of scientific illustrations. There are companies that hire scientific illustrators, and they get hired by the huge publishing houses. I need you, this company, to do all of the artwork for my new textbook that I'm publishing. That's a huge thing. And whether we go into a digital delivery or stay in print, notwithstanding, you still need the illustrations. The figures aren't going anywhere, even if printed textbooks aren't going anywhere. So, public relations, photography. If I talk to students every once in a while who say, well, it's too bad that I can't use, my love of photography to combine with my biology degree. And I say, wait a second, yeah, you can. You can take the nature images that get used in textbooks and publications and stock images for research labs, and you can take the pictures that make it into everyday media. You could be famous just as a photographer, even though you have your training as a molecular biologist. Animation and simulation, you might even want to throw that in with the it's not really bioinformatics, but it's certainly computer technology. Once again, if you're good at computers and you know how to do animations, there's a market for that. People need, visual learners need a way to see something happening that they can't see in front of their eyes. There's a market for that. We have a number of biology majors who go to law school. That doesn't, on the surface, seem like a logical mix, but it is, because somebody has to be an environmental lawyer, somebody has to be a patent lawyer, somebody has to be respectful of intellectual property issues. There are a number of fields of the law that a knowledge of biology would be critical for and would make you a great candidate for a law school. And so science policy. Maybe you're the one who goes and talks to some Senate committee on environmental affairs and talks to them about how bad this new legislation is that is being proposed. You could be in science policy. Again, if you've got good science knowledge, good communication skills, and you get in touch with the right people, who knows who you might be able to influence. And we all want to make the world better in some way, right? There's a lot of ways to do that. So, legislation, law, I've got one more panel here, business and industry. You might be thinking, but I'm a scientist, I'm not in the college business, and I say, who cares? There are ways to use your knowledge of science in business. A lot of people get jobs right out of college. They may or may not make careers out of them. I hope you're all familiar with the difference between a job and a career. There are jobs out there selling scientific equipment. Now, it's not like selling knives door to door. You're going to industries, you're going to academic institutions, and you're saying, couldn't help but notice that you got that centrifuge in there. That thing looks like it's about 30 years old. Have you considered a new one? They were probably in the market for it anyway. You're selling them something that they needed. You just need to convince them that the one your company sells is better than the one that other company sells. So if you're in marketing and sales, you can even combine that with illustration. You could be the one who puts the promo poster together for why your centrifuge is better than the competition. There's ways to combine. I know I keep coming back to this, but this is such an important point. There's ways to combine what you love with what you're good at, if they aren't already the same thing. Healthcare administration, bioremediation, that's using living organisms to clean up ecological messes, in a nutshell. That's what bioremediation is. Bioremediation is a great industry. Clearly, the government would be the Environmental Protection Agency, for example, would be keen on hiring someone who has a knowledge of the bioremediation field. And again, same things. High energy level. If you're going to be in sales, you got to sell it. I know that sounds redundant, but you have to sell yourself as much as your product. Sales experience is a good idea, but mostly the number one point right there is the number one point for a reason. Communication skills are key. Yes, it's great that you're going to have a degree in MCB, and there's going to be some things that we know about you based on that. We know you've got good problem-solving skills. We know you probably are familiar with the scientific literature, how to interpret data. But also, the fact that you're getting a college degree through the College of Liberal Arts and Sciences should tell the world that you've got good communication skills and good leadership ability and good teamwork skills. Those are the things that are going to get you a job. More so than do you remember the Krebs cycle. That's not going to get you a job. Knowing how to communicate with others, that is going to get you a job. Being efficient, that's going to get you a job. Demonstrating that you are good working with a team and that when necessary you can take leadership roles. Those are the things that are going to get you the jobs. You combine that with the skills that you get in your major classes, and that makes you marketable for particular jobs. So, like I said, this is all freely available for anybody. I'll give you that website in just a second. I want to close this part and then open it up for questions with the minutes that we have left. I want to remind you that everything that I've been describing can be summarized in this Venn diagram. What I want for every student I ever talk to is for you to find something you're good at combined with something you love doing. All right, you'd want to be in that intersection point right there, right? But what if there's no market for it? So we actually have to add a third circle to our Venn diagram. You need to find something that somebody's going to pay you to do. And then we find a way for you to live inside that triangle. That's what we want. That's what I want for every one of you and everybody I ever talk to about life after college. I want you to find a way to make a career out of something you're good at, something you love, and something that someone will pay you to do. If you do that, you will be a happy person for the rest of your life. You won't be the person who dreads going to work in the morning and watches the clock every 30 seconds to see how close to 5 o'clock is it. And don't we all want our professional lives to be as rewarding as our personal lives? I would think the answer would be yes, right? So that's what I want for you. Just as my thank you, there is the what can I do with this major? That's the website of the Tennessee Career Services information site. And if you would like to talk with me or any of the other MCB advisors about details of anything that we talked about, or you just want to talk about your own personal situation, we have a website with an online scheduler. It's really convenient. You can schedule stuff with the advisor of your choice up to 5 weeks into the future. And there's the quick link to it right there. Thank you for being here. I hope you have a great evening, and I'm happy to take whatever questions you've got.